Hi, my name is Omri. It's my first Houdini tutorial, and in this tutorial we're gonna create this effect of VDB Advection, and we're gonna change the object's material properties based on the time of activation. The method is called like timestamp or age attribute or whatever. That's the effect we're after. I didn't thought of this effect myself. I was just trying actually to replicate Panoply Studios effect. In this talk, Simon Homalder is talking about how we achieve this effect, and it's not that in-depth. So I was like making a lot of effort of trying to find different resources and understand how we achieve this part of changing the material properties of the object. And yeah, so actually great. I want to thank him just for developing this effect and like talking and all. Another resource that I found, which relates to this subject, is this man versus machine talk of Tim Boland. He's talking about the age attributes, and yeah, the same thing, but it's like explaining better about how to achieve it. And check it out. All of these talks and tutorials that I'm showing, it's just because I'm not gonna have enough time to go too much in depth. And on your own time, just check it out. All of the links will be in the description of the video. So yeah. Another resource is Junichiro Rikawa. Is really explaining a lot about SDFs, SDF volumes, advection, all of this type of thing. Check out his talks, his tutorials. Is really good, really recommended. Also about Vex, if you want to study about Vex, I think I started studying Vex with his tutorials. Yeah. So check it out. Another really cool tutorial is about mainly about the advection. It's Tim Valhensingen talk about creating custom solvers and specifically volume advection, VDB advection. He's talking a bit more in depth about the advection part of things. Yeah, so I think that's around it. And now we're gonna open Houdini and start creating this effect. Okay, so we're in Houdini, and what we have here, it's basically just a project. I modeled this like sculpture, sort of like this thing. It's really simple. By the way, the project file will be available in my Patreon if you want to grab it later. But it's actually just this thing, nothing too complicated. You see, low poly thingy. Yeah, and now we're gonna recreate the entire effect. And so let's start with extruding it a bit. We're gonna use poly extrude. I found out that it gives us a bit more of a volume, and you see it extruded a bit. Later on down the line, it will be easier to just get the perfect edges after converting the VDB back for polygons. Yeah, so this is the first part, extruding it by 0.05, and now we're gonna convert it to VDBs. So VD polygon, yeah, this one. And on the voxel size of this one, we're gonna do 0.02. Yeah. And the other, yeah, it's surface VDB. Now we're gonna create this wire that you see in the beginning. So we just gonna append the wire node, and in the wire node, the radius gonna be 0.05. Yeah, like this. And it actually sweeps and these tubes around the wireframe of the geometry. So we have this one. After this, we're gonna have also VDB from polygons. Let's do this. I just copied this one. Yeah, I think it's good enough. Okay, so this is our main shape. This is our wire shape. We're doing the wire one in order for you've seen the effect here. You see the wires are appearing before the inner shape. We want to create that. So that's why I'm doing it. Okay. And now we're gonna do I'm gonna create a box. Just a simple box. Then I'm gonna VDB it. So I'm working with another file open, so in order for not wasting your time pasting, like typing everything. So just copy paste from the different file. It doesn't work. Fuck. Can do it manually. Okay, so this one like this one like this, and this one is gonna be 0.15. Okay, so we have this box here, and this box actually will be converted now into VDB. Great. And now we're gonna VDB what's intersect SDF, this one. So we're using this one and this one in order to have only the lower part here. Great. Now we're gonna, so now I'm gonna convert this shape also into a fog VDB. So we're just gonna copy this one, and instead of surface, we're gonna create density, and we're gonna do the same for this one. So we're gonna do the same here. Yeah, actually, this one we don't need. So we have like this fog VDB, like density, and this density VDB. And an important part will be fill the interior of this one, because we want to compute all of the values inside of the shape. Yeah, so now we're gonna create a volume vol, and we're gonna dive inside stubbing. So what we want to do here is let's do the flag here. We actually have this density, and we want to add the wire density that we attached here, this one, and we want to give this density larger value than this one, so it will grow faster, maybe. Okay, so we're gonna bind. So actually we have the density here, and we're gonna do a multiply constant. And okay, that's good for now. And from the second input, we want to volume sample it. Vol sample. It's a float, so it's good. Based on the position. So we're gonna attach it. Yeah. And we wanna have the name, and we wanna get the density. Now we have this density. We're also gonna have another multiply constant here, and this one is actually the wire one. So we wanna have it to have bigger value. So we're gonna multiply it by 4, and after all, we're gonna add these two together. So we're gonna append this one and this one, and now this is gonna be the density. Okay, cool. So we succeeded to combine these two densities together and achieve this thingy. Great. Now we wanna start with a solver. Yes. Okay, let's append the solver. So in the solver, let's bring solver. We're gonna create our own custom solver. Yeah. So we're gonna dive in the solver, and now usually what I do is like I start the solver on the second frame. I don't know if it's necessary, but it's just a good habit, so I do it. And so we're gonna have a switch here. We're gonna connect the first input here, and we're gonna write $F, sorry, capital F, and we want to, if it's smaller or equal 1, then it will be 1. And so it's like on the first frame, it's gonna be 1. We're gonna take this input, and later on, it's gonna take this input. Yeah, okay. Now we're gonna do the VDB analysis. VDB analysis. We're gonna I output it with we're gonna attach it here, and now we're gonna get the gradient. So gradient in VDB, it's like the normals in a way. It's like things that are pointing outside of the surface, and this is gonna influence the direction in which the VDP is growing. So we're just gonna call it, give it our own name, call it normal. That's cool. Now we're gonna bring a volume drop, another volume drop, and we're gonna append the second input of the solver to the second input of the volume drop. Diving inside. Okay. So here we're gonna do a couple of things. We're gonna bring a bind and bring in the normal that we just created. So we're gonna bring the normal, and it's a vector and not a float. So we're gonna specify it as a vector. And now we're gonna bring another volume sample. Vol sample. And we're gonna connect it from the second input. Remember, this is our like density. So we wanna, it's gonna be based on the position. And we will bring the density attribute, density. Okay, sorry, I misspelled this. Great. And now, actually, what we wanna, I think we don't need this one. So we're gonna multiply the normal with the density. Sorry, with this density. And we're gonna bind export the normal, in my opinion. Yes, normal. And so actually what this is doing is it's just making sure that we're multiplying, that we're not so outside of the density volume. I will go back. Outside of this, let's say if we're up like here, we have 0 value of density. So if we multiply by 0, we're just making sure that the growth effect will not go over like the general shape. If we won't multiply it, we can try it out. If we just do a regular, gradient with our old gradient, we check out the solver. Okay, we're gonna VDB Advect it now. VDB Advect. And we're gonna advect the previous frame, and we're gonna advect it like this, and this is the volume. Here we need to append the velocity, and let's see what's going on now. So you see it's affecting now. Okay, so you see now it's growing to every direction, to every like normal or gradient direction. And we don't want that. We want to limit it only for the shape here, only for this shape. So that's what happened when you multiply it. It gets zeroed in the areas where it's not multiplied, outside of the shape, and it won't be advected in this direction. So let's check it out. Okay, so seems like it's working pretty good. Remember what I told you before about the extrusion we did here? So later on we're gonna subtract the old shape. Also VDB, subtract it, maybe get even a better resolution from this one, which is a bit blobby, just to get the sharp corners. Okay, so right now it's all happening good as we expected, but we're really missing another ingredient in this, and it's a bit boring. Like now it's growing pretty flat on, not interesting growing shape. And so what we need to do in order to make it more interesting is go here, and we're gonna multiply it by another thing, which is the curl noise. Okay, and based on trial and error, I found these values, 222, and the roughness, it's around here. Doesn't have to be so like accurate. Anytime you do a tutorial, just try it out and change the parameters a bit, and don't do the same as the tutorial is doing. Achieve your own cool effects. Okay, so I see that something is a bit weird. That's because we need to fit the curl noises value. Right now it goes between, I think, I'm not sure, I think it's between 0 and 1, and 0 it's too low, so it's like, it's weird, not good. We want to anyway have it like a positive value, so we're gonna fit fit range. Wait, I'm checking another thing. So here it's turning noise. It's turning noise. Okay. So we're gonna fit it between the destination of 0.6. This and the maximum value of 1.8. It's all based on trial and error, so it's not perfect and you can achieve different results by changing these values. So try it out yourself. Let's reset the sim. Okay, so that's more like the effect we're after. So that's, let's say, the easy part, sort of. The more difficult part was achieving the timestamp thing. And yeah, so let's start. Okay, another thing that I did now is the subtraction that I told you before. And we're gonna take this one and we're gonna another VDB from Polygon. And the only difference now is that this one I did with a larger resolution. You see the corners are a bit sharper and you don't want it exaggerated because it will take a lot of time, and the smaller the voxel size is, the more time it will take to calculate because it's like computing more voxels, so don't go too crazy about it. And yeah, so now we're gonna do the VDB intersection. SDF intersection, and we're actually gonna take the blobby shape, take this shape, and just find the intersection between them. So it won't be that, yeah, that's looking way better, in my opinion. Okay, cool, but now we don't have the age thing. So how did I achieve the age attribute? I took this one and created points from volume. Points from volume, this one. And it actually just generates points inside the volume, as you can see. And the point separation is, in my opinion, it's the same as this one. Yeah, 0.01, 0.01, yes. And now the next thing I did was, okay, this is a base of the man versus machine talk that I showed you before. And I'm not gonna type the entire code, just gonna copy and paste from what I have here because it will take too much time. But I will try to explain as much as I can. It's a bit weird, but follow me and it will be fine. Yeah, so just a second. I have another recommendation actually for this part of the code. And there is a really cool extension for Chrome, for Google Chrome, which enables you just to copy directly from YouTube videos. So just activate it, it works really good. Sometimes you need to adjust some letters and stuff, but overall it saves a lot of time. So you can just copy directly from my video. Okay, so I went a bit into a rabbit hole trying to explain everything. It's a pretty complicated subject. Not that, but like you have everything from this part, everything is really based on this talk of Tim. So check out, listen to what he says, and it's actually the same code, the exact same thing that he did. So I'm gonna just show you the code and what I'm doing, not explaining too much. So now this is an attribute wrangler with this line of code. Now I'm taking another point wrangler, and we're gonna connect this volume. It actually samples the volume and checks. This actually create the mask, transfer the mask to points, and it works good. Now we're creating a ramp. It's based on another solver. Let me show you. Okay, so this now we're gonna make a solver. This one goes here, this one goes here. This is the timestamp one, so we're gonna name it like this. We're gonna dive inside. In here, what we're gonna do is we have the switch the same as before, and we have another attribute wrangler. Sorry. And this is one connected to the second input, and we're gonna append it to the out. Okay, cool. So now it's still not normalized, and we need to delete the high points. Okay, so now we have it normalized. And another really important thing related to this one, you see the line of code here that I connected in to the left. So this number has to be the same number as the frames, the final frame. Either this number or higher. Otherwise, this system won't work good correctly. So and check out that any number you put here, be consistent and put it like also here. So this one zeroes it out and normalize it. And now it's the fun part where we can redirect it, this attribute, and we can do like all kind of crazy stuff. And yeah, so it's like this. It's pretty cool. And in this video, I did like a constant one just to show the effect. This one is like a subsurface material and no textures. And here we have textures. And later on, I'm going to show you how I transfer the UVs. And another important thing in this code, can copy paste this one, is the fade length that actually can change it. This determines how long the effect is gonna last. And now for the final part, I'm gonna just delete this one, delete this one also. Yeah, just gonna make it simple, the same as I did. I think mine was 40, yeah. And now we're gonna attribute transfer the mask. But before we do that, we actually we want to attribute transfer this information to this one. So we're gonna VDB convert polygons, and we don't want to play now with the adaptivity because we want a lot of points that can receive the data from this mask. And I'm sorry, we're gonna put this one on the left, like this is the main geometry, and that's the attribute we want to transfer. And we want to transfer the mask attribute, so we're gonna write mask. And now we've got it on our final mesh. And to further like make it a bit smoother and nicer, I appended the attribute blur, this, and instead of position, I want to blur the mask, and you can dial it a bit, change it for how you like. Now, if you want to add some UVs to it, I'm just gonna grab this object merge, duplicate it, bring it here, and we're gonna just attribute transfer the UVs. So at transfer the UVs, we want to transfer them their vertices attribute. So we're going to type down UV. And now we have UVs on this. And you see the inner part is a bit weird. And I'm not going to cover this in this tutorial. What I did here is like making this the first material no, it has no textures. But you can probably solve it somehow. If you want, you can delete those UVs from the inner part. So just decrease the max distance, let's say this, something like this. And you see you can play around with it if you want it only on the outer shell. So I'm just decreasing this value until it looks nice and it's only on the outer surface. Yeah, so now that's the effect, actually. I want to say thank you very much for staying with me till the end of the tutorial. If you want to grab the project file, it's going to be available on my Patreon. And that's it. Enjoy.